The first question is, which two conditions are necessary for high availability to function between two Cisco FTD devices? To answer this, the second question is, an engineer must configure high availability for the Cisco Firepower Threat Defense devices. The current network topology does not allow for two devices to pass traffic concurrently. How must the devices be implemented in this environment? The third question is, what are the minimum requirements to deploy a managed device inline? Hello everyone, and welcome to today's online class presented by 591lab.com. This is Cisco Certified Network Professional Security, securing networks with Cisco Firepower, which we call as SNCF 300-710. First of all, let me tell you more about 591 Lab. 591lab.com, pronounced as 591 Lab, is the top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Today, we will be covering Firepower high availability and Firepower deployment from the securing networks with Cisco Firepower exam objectives. These concepts will help you prepare for the securing networks with Cisco Firepower certification exam. Now quickly, let's deep dive into our first question. So, the first question is, which two conditions are necessary for high availability to function between two Cisco FTD devices? To answer this, let's have a look at Firepower high availability architecture. Firepower Threat Defense high availability provides redundancy and failover capabilities to minimize downtime in case of a primary Firepower next generation firewall failure. Firepower Threat Defense high availability is supported on all physical Firepower models and deployments on VMware EXXI. Stateful active standby failover. Firepower Threat Defense high availability utilizes a stateful active standby failover mechanism. This means one next generation firewall operates in active mode, handling all traffic inspection and security duties, while the other next generation firewall remains on standby, synchronizing its state with the active unit. If the primary next generation firewall fails, the standby unit automatically assumes the active role and takes over traffic processing. All features supported with the failover. Importantly, Firepower Threat Defense high availability offers failover with all features enabled. This includes features like firewall policies, threat detection, application control, and intrusion prevention. There is no degradation in security functionality during failover. Requirements for Firepower Threat Defense high availability. Identical next generation firewalls. To ensure compatibility, and seamless failover. Both next-generation firewalls in the high availability pair must be identical in software version, memory configuration, interface configuration, and mode, which can be routed or transparent. Same hardware model of next generation firewall. Cisco FTD high availability requires both devices to be on the same model. Different models may have varying hardware capabilities that can cause issues during failover. Active standby in different chassis, which is Firepower 9300 only. An exception applies to Firepower 9300 models. For these models, only high availability allows the active and the standby units to reside in different chassis, but not within the same blade. Long distance failover. That means Firepower Threat Defense High Availability typically operates in a local area network. However, for Firepower 9300 models, Firepower Threat Defense High Availability can support failover across geographically distant location if the latency between the two next-generation firewalls is less than 250 milliseconds. It is recommended to configure both next-generation firewalls in a high availability pair to have identical configurations for a seamless failover. A health check mechanism continuously monitors the primary next-generation firewall. If the primary fails, the standby unit automatically detects the failure and initiate a failover. After failover, the newly activated next-generation firewall assumes the role of primary device and begins processing the traffic. Network traffic interruption is minimized during the failover process. So, the answer here is option A. The units must be the same version. Major, minor, and maintenance release should be same. This ensures compatibility and consistent behavior between the two devices. And the next option is E. The units must be same model. Cisco Firepower Threat Defense High Availability is only supported between identical Firepower Threat Defense model. Here is why the other options are incorrect. Let's discuss about that as well. Option B. Both devices can be part of a different group that must be in the same domain when configured within the FMC. While both devices can be in the different groups, they do not need to be in the same domain within the Firepower Management Center. Option C. The units must be different models if they are part of the same series. This is not a requirement. As long as the Firepower Threat Defense devices are exactly the same model, they can be configured for high availability. And the last one is option D. The units must be configured only for the firewall routed mode. Firepower Threat Defense High Availability supports both routed and transparent firewall modes. Let's look at the next question. So the second question is, an engineer must configure high availability for the Cisco Firepower Threat Defense devices. The current network topology does not allow for two devices to pass traffic concurrently. How must the devices be implemented in this environment? Let's continue with firepower high availability architecture to answer this question. The slide depicts a firepower threat defense high availability configuration with two firepower threat defense devices connected for failover redundancy. The two devices are connected by one or two dedicated connections called failover links. These links are used to synchronize state information between the primary and the secondary firepower threat defense devices. The text failover and state refers to the processes of transitioning from the primary device to the secondary device in the event of failure. When a failover occurs, the secondary device assumes the role of primary device and begins passing the traffic. State information, which includes things like firewall policies and connection tracking tables, is synchronized between the two devices to ensure a smooth transition. Can use the same link for both indicates that it can be possible to use a single failover link to connect the two firepower threat defense devices. However, the text best practice is to use a dedicated link for each if possible. Advises that it is preferable to use two dedicated failover links. This is because using a single failover link can create a single point of failure. If the single failover link fails, then the two firepower threat defense devices will no longer be able to communicate with each other, and failover will not be possible. The diagram depicts a firepower threat defense high availability configuration in active standby mode. In active standby mode, one device is the primary device and the other device is the secondary device. The primary device is responsible for passing traffic, while the secondary device is responsible for synchronizing state information from the primary device. The text, when first configured, primary's policies are synchronized to secondary, refers to the initial synchronization process that occurs when the FTD high availability configuration is first set up. During this process, the configuration and policies from the primary device are copied to the secondary device. Configuration and policies updates are sent to the current active node by FMC. Refers to how configuration and policy updates are applied to the firepower threat defense high availability pair. The Firepower Management Center is a centralized management tool that can be used to configure and manage firepower devices. When you make configuration or policy changes to the firepower threat defense high availability pair using the FMC sends the changes to the active devices. The active device then replicates the changes to the standby device. Active unit replicates policies to standby refers to the replication process that occurs between the active and standby devices. The active device continually sends its configuration and policy information to the standby device. This ensures that the standby device is always up to date and ready to take over if the primary device fails. Hence, the correct answer is C, which is in active-passive mode. Here, passive means standby. Active-passive modes, also known as failover mode, is a high availability configuration where one device actively processes traffic while the other device remains on standby, replicating the configuration and state of primary device. If the primary device fails, the secondary device automatically takes over, minimizing the downtime. Let's look at why the other options are incorrect. Option A, in active-active mode. In active-active mode requires both devices to be able to process the traffic simultaneously, which is not possible in the scenario given in the network topology limitation. Option B, in cluster span ether channel. Cluster span ether channel is a technology used for aggregating multiple physical links into a single logical link. While it can improve bandwidth and redundancy, it does not address the need for high availability with only 2 firepower devices. And option D, in cluster interface mode, is not a standard mode for Cisco firepower devices. Hence, we just left with option C, which is active-passive mode. So, the third question is, what are the minimum requirements to deploy a managed device inline? To answer this, let's have a look at firepower inline deployment mode. Inline interfaces. These are the physical network ports on the managed device that will be used to pass traffic. When a device is deployed inline, it sits directly in the path of the network traffic. Traffic enters one interface, is inspected by the device, and then exits another interface. MTU, which is also known as Maximum Transmission Unit, is the largest size packet that can be transmitted over a network. It's important to configure the MTU of the inline interfaces on the managed devices to match the MTU of the network segment to which it is connected. This will help to prevent packets from being fragmented, which can degrade performance. Mode. The mode of the inline interfaces determines how the device will handle traffic. In inline mode, the device will inspect all traffic that passes through it. Other modes, such as passive mode, allow the device to monitor traffic without interrupting it. Hence, the answer is C, inline interfaces, MTU, and mode. The other answer choices are incorrect because passive interface is used for a passive deployment. In a passive deployment, the managed device is deployed out of the band from the flow of network traffic. It monitors traffic on the network but does not directly inspect or filter it. Security zones is a logical grouping of network devices that defines the level of trust that is assigned to the devices in the group. Security zones are used to control traffic flow between different parts of the network, but they are not requirement for deploying a managed device in line. Hence, the answer is C. Thank you all for attending today's class at 591 Lab. We hope you found this material informative and helpful. Remember, practice is critical to mastering any new skill. So review the course content and keep practicing with 591 Lab help and support. If you have any questions or concerns, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. Have a great day ahead.